And that concludes this part of the build.
Which means we can now carry on with the piston rod and onto the cylinders, which look like this currently. There's a fair bit to machine off these. And while you weren't looking, I got a piece of rod and I put a thread on the end, and this screws in here because you didn't need to see me machine another thread. So this goes on here. And it's supposed to go all the way. And that's going to get Loctited in there. Whether that's going to hold up entire time it's in there, who knows? I'm used to it having a taper pin or something like that in here. Maybe something we can do later on. I can now get a measurement from here to the end of where it should be, because I've worked out what it should be. Hopefully this is all going to work out in the end. So with that in there, we can get a datum off here to there, chop it off, do a bit of machining, and do piston. And we've got new mics as well. We'll see how they turn out. When we machine the crosshead, the dimensions from the centre line of the hole of the pin to the face, front face here, which is this one, is the same as the original drawing. And on the original drawing, the datum comes off this face here, which is here. Gives a distance between faces of the piston and this one. So with our rod screwed in here, we can now get a distance of how long this rod needs to be. Between faces, which is down here, the rod is 7¼ inches. So that's to the edge of the piston, and then the piston is 1 inch long. So from here to around where this mark is, it should be 8¼ Now with the power of mathematics, we can work out all of this added together. So from this bottom edge, the granite table, to this face here is 2½ inches. So 2½ inches plus our 7¼ plus our 1 inch gives us the grand total of 10.75. So I shall set this to 10.75 and put a line on here. Somewhere there. And then carefully rotate this round. Now you probably can't see it, but I've got my mark. There we go. Right, so we want to take a very light skim off the end of it. That should be right. Right, so this is for our thread on the end, and then it's got to slope up that way. So we're just going to get an estimated, quite a bit to come off. Right. Right, we'll just let that cool down a sec before I measure it.
1 minute 37 seconds later.
Right, it's cooled down now, we can give it a measure. See how far off we are. I'll take 5 thou off. Need to put a thread on that now. Right. Take this edge off here. Now, unconventionally, I'm going to do this with a die, not a cutting tool. As crazy as that sounds. Right, let's hope this goes well. I've got the compound slide set to 4 degrees, so we can put a taper. Hopefully this is going to work. I've got everything set up, all the dials set up, so I can return back to this position 0 here, which is where it's supposed to set from. We have a line up here, which I don't know if you can see, which will give me some idea of where it's going to get to. So let's put a taper on and see what happens. So eventually we'll end up with a rod that looks something like this, with an M10, the taper, the shaft obviously, the piston rod itself, and then the thread that goes in here. And then with a little bit more work you get two. Now I've just been to the laser cutters and picked up a few pieces. Some of them are for this project and two of them are for the MANWAR project that we have yet to crack on with. So I'll show you what I've got. Quite self-explanatory really. These are our connecting rod, our big end, little end. Now I'll show you why I've had to order some new ones of these, because you may have seen in the video that I have already done these. But yes, a new pair of those. These here, these two items here, if you can guess what that is. If not, it's the motion brackets. These have just literally been drawn in a simple 2D CAD package, exported as a DXF and sent to a laser cutter. Nothing fancy, nothing hard. These are to the size of my dimensions. And this, and the piece underneath, these are the two new buffer beams for the MANWAR project. The original buffer beams go right up here and have a weird curve, and I want it to look slightly different, and the rear buffer beam is actually lower because we're going to have a step. But yeah, that's them done. Eventually we will do a video on that, but not until we've got a lot further with the Tinkerbell. So this motion bracket, that's going to go somewhere about here. There's a little bit of fine tuning. I did a lot of measuring, and the only thing I did miss was the inside radius off this, so I just need to radius that piece there. There is a lot of work to do. Even though this is the outline of this piece, it's got angle iron here and here to bolt it to the frames, and it has a piece across the top which sits up here, which will take the plates or part of the plate for the foot plate. There is a boss where the valve spindle rod runs through, which needs bushing, and on this front face here, where this notch out here, that is for the angle iron which will run down the edge of the locomotive. And I need to weld some tabs on here coming off to bolt that angle iron here. You can see I've cut a notch out here, that's for the rod to run up into. So if I take the clamp off here, you should be able to see we've got a fair distance for when the weight of the boiler in the tank comes down. We may need to trim a little bit more off, but we'll see once we get the weight on the top. So the connecting rod, obviously that's going to go on here like so, with its bearing at that end, and this end will fit the crosshead which we've now finished. So this end needs machining out and a bronze bush putting in, because I'm going to a bronze bush at this end. A lot of people use needle roller bearings, but they actually wear the pin out, which is why on the original ones I had, if you look, there's a big difference between the ends, because I've not got enough meat here to put a bronze bush in, whereas that I do. I can get my bronze bush in, because it's got to be, what, 5/8 in the middle, so we're going to need to come out quite a bit, but it's now beginning to take shape. I suppose I better start machining some casts. So this here is our piston drawing, and these are our blanks for our pistons. What we need to mainly be concerned about is facing this edge off, facing this one off, then putting in this recess and drilling the hole and putting the taper. There are our main things, basically roughing this out. We're not going to finish off the face here, and we're not going to finish off this face here. We need that piston to fit on the end here, and then we can get the measurements from each of them to where this sits. It should be okay. This piston will be fitted to this, and then we will finish all of the outside diameters and where the clue pit rings go, which we have the clue pit rings. Here's one of the clue pit rings, as you can see, quite wide. A lot of spring in them. But yes, we've got both of these. I got these pre-made from Lathe Models, which mainly do traction engine stuff, but they do come in handy for steam locomotives. Right, so we've got the Forjo set up, and I've got this spigot here as close as we possibly can, and all I'm going to do is I'm just going to skim that just to be straight, because at the minute it's tapered, so it's wider here than it is here. So we'll get that straight, so then we can get a good grip, because at the minute this is only gripping across this back section here. So we'll just get this down to size. That will do us. Right, let's get this spun round and set back up again. Now I don't think this is bad. Right, we'll get this skimmed, faced, and go from there. What a crock of shit. Now that's better, much better.